I know. By love, I mean relative to the other stuff that you do. I know that no one loves doing this on the beach except for me. It is.
When it works out.
I know. When things just work, it just is awesome. Okay. So long division. I started with one that's got a little bit of a twist to it. Why is this one have a little bit of a twist? Because it's not in the right order. Good. So when we're doing long division, we want our polynomial to be written in the appropriate order. So highest degree, write down. Couple things that can come up. Maybe it doesn't have an x squared term. Do you guys fill that in with 0x squared? Okay, good. And then 3x minus 2. So, as a reminder, we start by using just the leading term of our divisor, and 3x times what gives us 6x cubed? 2x squared. So then we take that and we multiply it by the entire divisor and line it up underneath the appropriate term. So 2x squared times 3x gives us our 6x cubed. 2x squared times negative 2 gives us our negative 4x squared. And then we use what operation? Subtraction. Now, I like to put my subtraction signs in between each and every term so that we don't forget about it once we get deeper into the problem. So 6x cubed minus 6x cubed is gone as it should be. Negative x squared minus negative 4x squared is 3x squared. Negative 1 plus 4 technically. And we bring down the negative 5x and repeat that whole process. 3x times what gives us 3x squared? Just x. Very good. We multiply x times 3x minus 2. We get 3x squared minus 2x. Subtraction signs in there. And what's left here? Negative 3x. Bring down your plus 4. 3x times what? And we're repeating. 3x times what is negative 3x? Negative 1. Multiply. We get negative 3x plus 2. Throw your subtraction signs in there. And 4 minus 2 is 2, which is our remainder. How do we write that as a part of our quotient? Plus, wait. Yeah, you put your remainder over the divisor. Do you remember those vocab words? This is called the divisor, because it's what you're dividing by. This is called the quotient, because it's your answer. Do you remember what this one is? Dividend? I think so. Kind of forgot myself. Yeah. Okay? Easy peasy? Is it all that you remembered it to be? So here's the thing. And just to remember kind of what this all is doing, long division is another way of factoring, okay? So what we just did is we found out that this guy factors into 3x minus 2 times 2x squared plus x minus 1 plus 2 over 3x minus 2. So it factored into those. Okay, so when things don't appear to be factorable by our traditional methods, we resort to long division to factor. Okie doke? The issue, though, is if you are resorting to long division to do your factoring, you have to know what to divide by, right? Someone has to give you a little bit of a heads up or some way of knowing what to start dividing by first, because no one's just going to pick 3x minus 2 as a factor to divide out of left field. Okay? Next example does skip the x squared term. So there's ways around inserting it. We'll see if we can get away with it here. So starting the same way, 3x squared times what gives us 6x to the fourth? 2x squared. So when you multiply 2x squared by the divisor, we get 6x to the fourth minus 4. Now here we go. Oh no, this is fine still. Minus 4x cubed. So we're still all lined up, so no problem yet. Do your subtraction. 5 minus negative 4 is 9. And we would technically bring down 0x squared, right? This is where we can sort of slip it in there. So we repeat, 3x squared times what is going to give us 9x cubed? Kyle?
3x.
We get 9x cubed minus 6x squared. Put your subtraction signs in there. And what's left here, Haley? Bring down our plus 3x. Stephanie, what goes up here next? 3x squared times, not quite. 2x would not be okay because 3x squared times 2x is 6x cubed. We want 6x squared. Just 2. So we get 6x squared minus 4x. Do our subtraction. 3 minus negative 4 is 7x. Bring down our minus 5. And then you go to ask yourself 3x squared times what gives you 7x, and you can't do that without using a negative exponent. So we're done. And you actually kind of know you're done because your polynomial quotient, hit the x squared term, hit the x term, hit the constant, and then comes a remainder. So we would add 7x minus 5 over 3x squared minus 2x. And that's our quotient. Okay, we're going to be entering into something where we're going to have to do a lot of division within one problem. A lot of division in a short amount of time. Okay? So, we learn a new technique, I think. Did you ever learn synthetic division last year?
Maybe, but a different name, right?
Yeah, no. I don't think you learned it. We keep it in our back pocket for a good reason. But there's a way to do long division much faster, okay? So it's a synthetic division is what it's called. It only can be done when this is a linear divisor, though. So you can't do it if you're trying to divide out a quadratic factor, like on the last one, for example. We cannot do it if we're trying to divide out a quadratic factor. We can do it, this was a linear factor, we can do it with something like this, but it is a little bit more tricky because this has a coefficient. So it is best used when you're dividing out a very basic linear factor with a coefficient of just 1 on your x. Again, it can work here, but there is something we'd have to adjust first. But for the most part, it's always when we're dividing out a very basic linear factor. So here's how it works. If this is the factor, what is the root? -3, right? If this is to be a factor of this, then the root would be -3. So we put the -3 outside our little division house thing. And then we only pull, for the dividend, we only pull the coefficients. So the 1 for the 1x squared, a 10 for the x, and a 21 for our constant. Okay, and that's kind of the setup. And then here's how it works. You always start by bringing down your first coefficient. And then this is where it kind of just goes quickly, but I'll go slowly for you. Then you take the negative 3 and you multiply it by the 1. What's negative 3 times 1? Negative 3, and you insert it up there. And then you add those two together. What's 10 plus negative 3? 7. And then you repeat. Negative 3 times 7 is? Negative 21, and you add those two together and you get 0. Okay? So how is that our answer? So if it started as an x squared polynomial as your dividend with a degree of 2, then when you get down here, this is always 1 degree less. So this is your x term, and then this is your constant, and this is your remainder. Okay? The last number is always your remainder. And then our answer is just, you just insert your signs. This is a positive 7, so your answer is just x plus 7. Okay? So I started with something that did a couple things. Number one, we could have factored this by hand, right? X plus 3, x plus 7, right? So I started out with something that was clearly an obvious factor, bringing in the idea that you talked about last year, that if your remainder is 0, then this is a factor of this. Remember all that? Jack, how do you feel about this? Did you talk about if there's a remainder of 0, then something is a factor? No. Okay. All right. Yeah.
Are you ever going to ask us on
Long division? Yeah, you're going to have to. Otherwise, you're going to do 15 long division problems in one question, as opposed to 15 synthetics, and this is going to be way, way faster. Once you get good at it. I know it seems confusing now, but it is way faster. Okay? So, that's kind of just a brief introduction to that, but we will do more, maybe, on the back. Will we? Yeah, we will. So in general, and I kind of summarize it up here, synthetic division is used to divide a polynomial by a linear factor x minus c. So if the factor is x minus c, then the root is just c, and you divide out from the coefficients of polynomials. So I tried to take some notes about what we just did. The remainder theorem you did do last year. If a polynomial gets divided by a potential factor, right, divided by a smaller polynomial, then the remainder you get is the same as the value of f of c. So for example, if I go back here, if the factor was x plus 3, then the potential root is negative 3. So the remainder I got of 0 is the same as the value of f of negative 3, right? So a couple things to just bring together here. If we got a remainder of 0, we know this is a factor. If we know this is a factor, then what's the x-intercept? Negative 3 is a root, right? If this is a factor, then negative 3 is a root. Hence the reason why there's a point, negative 3, 0 on our graph, because it's a root. Yes? Does that make sense? Okay? So when you divide out a factor, or whatever that potential, I always called it a potential root, because you don't know if it is truly a root unless you get a remainder of 0. But f of that number will give you your remainder. And you did that last year. Okay? Does that sound familiar? Remainder theorem. Okay? So we'll use this concept. Here we have a polynomial, and we're going to use the remainder theorem to find f of 2. Now, typically, when you're first learning function notation, and still now, the most efficient way to find f of 2 would be just to plug it in, right? That would still be the most efficient way. Just plug it in. But this is specifically telling us to use the remainder theorem, which means we're going to do division, and we'll use synthetic division to practice to find what that value is. So if it's f of 2 that we're looking for, then 2 is the number that we're going to synthetically divide out. We have 1x cubed, negative 4x squared, 5x's, and a constant of 3. And here's going to be round 2 of me showing you long division. We always start by bringing down that first number, which happens to be a 1 again. We do 2 times 1 is 2, and we add those together. What does that give you? Negative 2. We do a repeat. 2 times negative 2 is negative 4. Add those up, we get 1, positive 1. 2 times 1 is 2. Add those up, you get 5. So this is my remainder. That last number is always your remainder, so f of 2 must equal 5. That's all this asked us to do, but I'm going to do one step further and talk about how we actually just sort of factor this. So we factored this into, if we were dividing out a 2, what was the factor? If the potential root was 2, what was the factor? X minus 2 times, and so this was our remainder, this was our constant, this is our x term, this is our x squared term. So we get x squared minus 2x plus 1 plus our remainder of 5 over the divisor of x minus 2. So if they ask you to use synthetic division to factor, these are the factors. Is that clear? Do you also see how, again, this started as a cubic polynomial, and when we divide out a linear factor, it becomes a quadratic? That should make sense, because you're dividing out a degree of 1, so this degree got knocked down a pedestal. It's down 1 degree to a 2. Okie doke? All right. Here's another example. Given that 3 is a 0 of this function, it wants us to solve the equation. Now normally if someone just said this, solve, you would probably try to factor and you would fail because it's not factorable by our traditional methods. So like I was saying earlier, if it's not factorable by our traditional methods, it may be factorable by long division. But they have to give you a starting point there, and that's why they're telling you this. If 3 is a 0, right, then what was the factor? X minus 3, okay? So they're telling you that this x minus 3 is a factor by telling you that 3 is a 0. So if you know it's a factor, divide it out. We're going to divide it out using synthetic division. So we'll put our root there of 3. And we set this up 2, negative 3, negative 11, 6. Now it hasn't come up yet, but for the record, if this does skip a term, x cubed, x squared, x and a constant, if a term were to have been skipped, you absolutely have to plug in a 0 as your coefficient, okay? Because it will totally throw off. We obviously got away with not doing it in long division a little bit. We adjusted accordingly, but with synthetic you have to throw a 0 in there. Okay, so this one is going to start by bringing down a 2. Nathan Z, what am I going to put here? 6. Alyssa, what do I put here? Good. Josh, what do I put here? Adam, what do I put here? Haley, what do I put here? Elizabeth, what do I put here? Perfect. So we knew 3 was a 0. So this is like a self-checking moment where we know, okay, we did it right. Since it was a 0, meaning this is a factor, we should get a remainder of 0, and we do, right? Then this is your constant, this is your x term, and this is your x squared term. So we have just successfully factored this into x minus 3 times 2x squared plus 3x minus 2. And we're using this to solve. So it still equals 0, And now that we've partially factored it using long division, the rest of this is factorable by hand. We can guess and check 2x and x. 2 and 1 will make 4 on the outside and 1 on the inside. We want it to be a positive 4 and a minus 1. And then we can tee it up. So our answers are x equals 3, x equals, what does this give us? 1/2, and x equals -2. Good? So things are factorable even if grouping didn't work. Things are factorable by long division. You just need a kickstart. You just need someone to give you a starting factor. Okay? Any questions on that? And really, this is what we've just been using. If you know that f of c equals 0, if you have a root, in other words, then you have a factor, and vice versa. If you're told that this is a factor, then you know that c is a root. Okay, so you've been using that. So here we go one last time. Given that -1 is a 0, and here's our function, it wants us to fully factor this. So if -1 is a 0, then x plus 1 should be a factor, and we're going to synthetically divide out -1. Here I did leave out a term. Did I? Oh, no, I didn't. Well, we don't have to plug in the 0, but you will have to run into that in your homework. We have 15x cubes, 14x squareds, -3x's, and -2 is our constant. Run through that and do synthetic division real quick on your own. You can look up once you're done to see if you got it right. Good? A lot faster than long division, huh? Don't give me that look, Steven. It's definitely faster than long division. He gave me like that, sort of, but you're not sold. So here we have x plus 1, and then this is our constant x term, x squared. So we have 15x squared minus 1x minus 2, and we should be able to factor that trinomial on our own. Once you get something down to a quadratic, quadratics you can definitely factor by hand always. It's that process of getting it from the cubic down to the quadratic that we struggle with. So has anyone guessed and checked and found the right answer yet? I'm going to guess 3 and 5. 2 will give me 6x. 1 will give me 5x. I like that. I want it -6x and positive 5x to make the -1. There we go.